Hi, I'm Chris Ranwell, Product Line Manager for Protometer products at Amphenol Advanced Sensors. Today we're going to be talking about the new MMS2 flooring kit and its installation in concrete floors. The kit comes in a hard durable carry case. Inside the kit is our MMS2. We'll see several of the capabilities of this instrument being used today. However, you can find more details at MMS2meter.com. In the kit comes a packet of 5 NIST traceable humidity probes for measuring humidity in the concrete floor. Also in the kit comes a drill and a drill stop to make sure you drill the hole to the correct depth, wire brush for cleaning out the hole, this tool called the extractor tool for removing and inserting the humidity probes in and out of the sleeves. The kit also comes with 20 humidity sleeves. These sleeves are fully adjustable so you can adjust them to the depth of the slab. Today we'll be outlining methods and demonstrating the F2170-11 standard. This standard is a North American standard, but it is being widely adopted globally. Please check your national standard before using this kit. The ASTM standard requires that you check the probes within 30 days of use. We, however, recommend you check that before every job. So included with the kit is this salt solution calibration check that checks each probe at 75% relative humidity. Before we start the practical demonstration, just a quick word about safety. Please make sure you refer to your local standards and the instructions on your equipment that you'll be using, and wear all the appropriate protective equipment. For our demonstration today, it's my great pleasure to introduce Peter Craig. Peter is the owner of Concrete Constructives and has over 40 years of experience working with concrete floor slabs. Peter is also a lead instructor for the ICRI Moisture Testing Certification Program. Okay, let's get on with the demonstration.
Let's do it. We're now going to demonstrate the use of the Protometer MMS2 unit to measure the concrete internal relative humidity according to ASTM F2170. This standard determines the relative humidity at specific target depths. The value of this test method, it is the predictor of what the relative humidity will be in the slab top to bottom once the slab is covered. For concrete slabs on the ground or those on metal deck that are drying from the top surface only, the target depth is 40% of the slab thickness. For slabs that are drying from the top and the bottom, the target depth is 20% of the slab thickness. Now we've already determined that this is a 5-inch thick concrete slab on the ground, so therefore 40% 5 inches is 2 inches. Now we've also used the MMS in its hygrometer mode to measure the ambient temperature and relative humidity and the slab surface temperature to make sure that we're in compliance with the current ASTM F2170 requirements. Another function of the Protometer MMS2 is to take non-evasive moisture measurements in the concrete slab. Many technicians like this feature. It enables them to determine the wettest parts of the slab to make sure that they're testing in those locations. Now that we've selected our test site, I'm now going to drill a 3/4 inch diameter to a depth of 2 inches. This is not the final vacuum. I personally like to use a micrometer because of the sharpness of the point that measures the depth. And here you see that the measurement is 2.0065. So we can be no less than 2 inches, but no more than 2 1/4. I'm now going to complete the final 2 steps in the cleaning process where I use a wire brush to scour the vertical walls of the drilled hole, vacuum that dust, and then reach to the very bottom of the hole to vacuum dust with the reducer nozzle. The last 2 steps in the process are to verify that our cleaning process has thoroughly cleaned the hole. So here I'm using a squeeze bulb to blow air into the hole to make sure that no dust comes out. The last step in the process is using a flashlight to look at the very bottom of the hole. You want to be sure that where the drill bit has stopped is not in the heart of a large piece of coarse aggregate. If you look down and more than half of the bottom of the hole is coarse aggregate, you're better off to drill a new hole so that you have at least 50% cement paste to ensure an accurate measurement. I'm now going to adjust the setting of the adjustable sleeve to a depth of 2 inches. There are also metric measurements on the opposite side that could be used if that's your preference. So We drilled a 2-inch deep hole, so I'm going to back this off to a depth of 2 inches. And then using a rubber mallet, I'm going to tap this down to refusal. Now that the sleeve is set, we have two options. We can cap the sleeve and leave this to acclimate to the time period required by the ASTM standard, or we can insert the probe onto the setting tool, push it to refusal at the very bottom, give it a back-off turn and remove the setting tool, cap the surface, and now wait the required time of the ASTM standard. We're now at the point where we're going to take the measurement. We've again used the MMS to measure ambient temperature, relative humidity, and slab temperature. I'm now going to connect the instrument to the probe that is already in the sleeve. I'm going to align with the marking till we make contact. And now it's a matter of allowing the instrument and the measurement to reach equilibrium or the requirement set forth in your applicable standard. Now that we've taken our measurement, that information can be recorded manually or maintained in the instrument itself. The last part in the process is to remove the reusable protometer probe with the extraction tool. And you're good to go again following a calibration check.
That concludes the demonstration and the installation of the protometer sleeves. Thank you, Peter.
Thank you, Chris.
You can find more information at our website, protometer.com.